Hello everyone. Welcome to my Algorithms and Data Structure 1 midterm coursework assignment. Today I'll be demonstrating my Rhyming Assistant project. It is a tool that uses a suffix try data structure to efficiently find rhyming words, count syllables, and find alliterations from a dictionary of over 200,000 words. The system has three main features: an intelligent rhyme finding algorithm, a syllable counting algorithm for poetic meter, and an alliteration search algorithm. Let's get straight into the project. The project consists of three main files: the trystructure.js file, which houses the data structure, the prosody.js file, which houses the engine for the program, and lastly, the main.js file, which simply sets up the command line interface for the user. Going back to the trystructure.js file, we can see the suffix try data structure. A suffix try is a type of try data structure. A try is a tree-like data structure used to store strings, usually words, character by character. In a rhyme assistant, the goal is to find words that share the same ending, not the same beginning. A regular try is optimized for prefix-based searches, meaning it efficiently finds words that start with a given sequence of characters. However, rhyming depends on suffix similarity, for example, words ending in ing or en, and this is where the suffix try comes into play. By reversing each word, as you can see here, before inserting it into the try, as you can see here, the suffix of the original word becomes a prefix in the data structure. This allows the try to efficiently group and search words that share the same ending using the same prefix reversal logic. As a result, a suffix try enables 1. Efficient rhyme lookup in O of k time, where k is the length of the suffix, 2. Natural grouping of words with common endings, and 3. Simpler logic compared to scanning all words or using repeated string comparisons. Now going into the prosody.js file, which is the engine of the program, we can see the getRhymes function. Secondly, we can see the getMeter function, which is the syllable counting algorithm. And lastly, the getAlliteration function, which is the alliteration search algorithm. In the main.js file, it simply sets up the command line interface for the user with the prompts. And this is the trystructure.js file. If we run the program, it simply builds the try from the word list, and this happens once at startup and it's ready. Now let's test the rhyme finding algorithm with the word men. After typing men, we can see the words that it returns: scren, splen, stren, rumen, crewman, and so on. Notice how the results prioritize words with the same syllable count. Scren, for instance, they are all one syllable words ending in n. Now, let's try another word: railing. After typing railing, we can see the words that it returns: grailing, trailing, ailing, failing, nailing, and so on. Notice that grailing appears before the word ailing because grailing matches a longer suffix compared to ailing. The algorithm tracks the longest suffix match for each word and ranks accordingly. Now going back to the word men, we can showcase the syllable counting algorithm. After typing men, we can see that the amount of syllables in the word is 1. Men. The syllable counting algorithm works by iterating through each character in the word and counting each vowel. Each vowel represents one syllable. For short words of 3, such as men, it defaults to one syllable. This simple approach works well for most words and helps with poetic meter. Now going back to the word railing, and it prompts the user, do you want alliteration for this word? We type yes. We can see that it returns words that starts with the suffix ra: rabana, rabbin, rabbinus, rabbinite, and so on. The alliteration algorithm is straightforward. It takes the first 2 characters of the input word as a prefix, then filters the word list to find all words starting with that prefix, excluding the input word itself, of course. In summary, this Poetry Assistant demonstrates efficient use of a suffix try data structure for suffix-based searching combined with intelligent ranking that prioritizes syllable matching and suffix length.